Welcome to a Foreman deep dive. This week's is on Staypuft, a specialized plugin for Foreman that's able to deploy and manage OpenStack instances. Mike Burns is going to talk us through. If you have any questions during the talk, either ask them on #theforemandev on Freenode or via the Q&A app. Over to you, Mike.
Okay, so Staypuft is, as Dominic said, a plugin for Foreman that is used to deploy OpenStack. We've tried to write it in such a way that it just drops into any existing Foreman instance. What I'm going to be showing is downstream versions of it, so you'll see a lot of Red Hat Enterprise Linux or Red Hat Enterprise Linux OpenStack platform, things like that. But the code is all completely upstream in the Foreman repositories. It's not overly well tested up there at the moment, but it is what it is. So this should look familiar to everyone. So by the way, I'm going to go through kind of just the high-level overview stuff. I'll try to highlight where I know that this intersects with something in Foreman, give you as much information there as I can. If you have deeper questions, feel free to ask. I know Marek is on the Hangout as well, so he can answer where my knowledge comes up short. So this is already all installed. The installation process, which I'm not going to walk through, is basically a wrapper around the existing Foreman installer. It asks a bunch of questions so that we get DHCP ranges, DNS setup, those types of things. It also does things like subscription manager setup for Red Hat-based installs. It does configuration of a base host group, which you can see here. It sets up these two base host groups. It sets up a number of other configurations in the installer itself. So once it actually installs, Foreman's deployed, we come in and we just say new deployment.
You're able to increase the font size a little, Mike. It's fairly low res, unfortunately, for viewers.
Is that any better? Can people see that?
Yeah, I should get there.
Okay. So here we're just configuring various things about OpenStack. This is pretty domain-specific stuff. So you give it a name. We configure whether you want high availability or not. Neutron or Nova networking is very specific to OpenStack. The type of messaging we want to configure, and some password-specific stuff. This just lays out what we're deploying on what type of node. In the background, when I click Next, it's actually creating host groups specific to this deployment. And these are what's going to be deployed into each host group. So we have a controller, a compute, and a Neutron network host group set up on the back end. Moving forward, this is more specific configuration. So I won't go through all of this. If you're not a OpenStack expert, then this is fairly confusing. I'm just going to fill in some dummy data here. So we've got a few different tabs with different options that you can choose. I'm just going to leave these as LVM for now. And then when you click Submit, it takes you to another screen. And now your deployment is created. What we're doing from here is we're making use of the Discovery plugin. So I've got one host here that's I've already discovered. It's and just as a disclaimer, all of these hosts are virtual machines running on my laptop, so I can't run much more than what I'm running at the moment. This is a host that we're going to assign to the deployment I've just created. So you come in here, and it's got a couple of different hosts. I'm using these other hosts for other tasks that are outside of OpenStack. So one is the actual Foreman instance itself. One is something that I'm running on a different deployment. But this is the one that was just discovered. I'm going to assign it to the controller role. In the back end, this roughly correlates with just assigning the host to the controller host group. There's a little bit more logic around it so that we know that it's in this pending state. So if I had additional hosts, what I would do is I would add them. I'd add some to the Neutron networker role and some to the compute role. Then what I do is I click deploy, and it would actually go and provision these machines and then run Puppet against them to configure OpenStack. I'm not going to do that at the moment, though. The host screen doesn't have very much information on it at the moment. This is kind of a stepping stone to full network management, which is coming in the relatively near future. But at this point, it's just more informational. It tells you the IP address of the various machines and whether they're assigned, they're deployed, or they're available to be assigned. The advanced configuration screen, this has all of the specific Puppet configurations. We've written a layer in between the UI and the actual Puppet that does a lot of defaulting and does a lot of dynamic setting of variables. For example, this AMQP host is based on this Ruby expression, and we tell you out front that this is exactly what it defaults to, is this value. On this screen, you can click Edit, and if, for example, your deployment requires that to be a different value, then you can come in here and say, this is my specific value. And we have this for every single different service that we're configuring. So there's a bunch of different things here. In the HA use case, there's a lot of virtual IP addresses that we need to assign. Those get defaulted as well. We pull them out of the configuration. So out of the DHCP configuration, we use the suggest IP functionality to default those. Just cancel. So that's just the quick high-level overview. So just as an example, if we go back into host groups, you'll see that based off of the base Red Hat 7, which is something the installer configured, we now have this test, and then we've got compute, controller, and Neutron networker. So these are all the host groups that we're using in the OpenStack installer. So when we actually run the deployment, we're using the new Dynflow Foreman tasks work to orchestrate everything. OpenStack requires certain things to come up before certain other things. So what we do is we go into, see if I can show this. This is another environment that I have that's already deployed. So what's going to happen when you hit deploy is we're going to send it into, actually, no, I'll do it with the other one. It will probably fail, but that's the way live demos go. So I only have one host, so it's not overly exciting. But when I click deploy, what's going to happen is in the background, we've got a Dynflow task running that's going to go and provision the controller node first. And only when that's done and Puppet is complete is it going to move on to the Neutron node. And then when the Neutron node is done, it's going to move on to the compute node. There's plans in the future to kind of break up the Puppet classes so that we can be a little bit smarter. There's nothing stopping us from actually provisioning all three at the same time, and just only running Puppet on the controller first. But there's some work to be done on the Puppet side to enable that. show more details. If you're familiar with the Dynflow interface, that's all this is. It's showing that we've got a controller that's provisioning. On the back end, this is the host. It's actually loading right now and provisioning RHEL 7 onto this host. So yeah, that's pretty much what Staypuft is at the moment. Are there any specific questions? I can show you various different things, kind of walk the different areas I know that we're touching, base form stuff, or I can answer questions. Kind of tell me what you guys want.
We don't seem to have any questions so far on IRC or via something from Ohad. Ohad asks if you could describe a bit the deployment objects.
Okay. Can you direct me to... Oh, okay, so the deployment objects. This is getting into where the fact that I know how to run this and demo it. I don't know very many of the internal details. Marek, is that something that you can talk to?
Or maybe some interesting part is about parameters. We use, of course, on the backend, we use the Puppet parameters from the Puppet classes for the NC. So the OpenStack is normally installed using the Puppet modules, but we have another layer of parameters. When Mike showed the wizard, there were a lot of radio boxes and text boxes. So this is something that is there just for nice and easy UI. So users can easily configure their deployment, and then when they run deploy, it's converted to the and translated. The values are moved to parameter values of Puppet parameters. Any specific thing that Ohad would like to mention? How are parameters transferred between hosts in a deployment? So, Mike, if you could go to yes, to parameters here, we can see, for example, there are some values are ERB template. So, for example, Cinder backend, you can see that there is some helper method which reads information from other parameters. We have some hard-coded methods that we can run in this mode. And because we use the Dynflow for the orchestration of the provisioning, we can be sure that, for example, controller is already installed, so now we have a value that we can use for ENC for Neutron, for example.
Also, the advanced configuration screen that I showed, had I actually saved that, you would see an override parameter down here for the value that I had overridden.
So do you guys see that as something we could easily reuse in Foreman for deploying of composite applications, where you want to deploy, let's say, not just OpenStack, but I don't know, multiple web servers and multiple databases, for example?
So we're using a lot of, or we're reusing a lot of Puppet code that already existed upstream, which has allowed us to kind of get up and running a little bit quicker. If there is Puppet code already done, or Puppet classes done to do a lot of the deployment, I think that a lot of this could be reused. I think we're doing a good job of kind of isolating the things that are more OpenStack specific into the Staypuft plugin itself, and everything else we're trying to push into Core Foreman, or the other existing plugins, so like Dynflow or the Discovery plugin. We've made a number of enhancements around those plugins already. So I think we're doing a good job pushing a lot of that stuff up. I think once we get to a consistent, stable point where we're not just in rapid development and rapid feature adding states, then we can maybe look at other things that we're doing in Staypuft that maybe are more generic that we could pull out. I don't know specifically of anything off the top of my head, though.
Okay. Can you describe the layer, as you mentioned it, between the Puppet parameters and what you see in the UI? Is it hard-coded, or is it, you know, how would someone add a new parameter if they need to?
So right now, yes, that middle layer is pretty hard-coded. We have the Puppet classes that exist upstream, and they do more or less kind of resolve into all of these options that you see here. And our first run of the UI actually exposed every single one of these options for a user to configure. That was quickly deemed unusable because only like 2 or 3 people actually managed to ever deploy anything with it correctly. So what we did is we wrote a layer that basically says, take these few things that we're letting you configure here on this screen, assuming it ever shows up. And these are the logical things that a user would need to configure for an OpenStack environment to work. So there's a few things, like when I choose VLAN here, I get a different option. When I choose flat, that option goes away. In Cinder, if I choose Equilogic, I get different options versus NFS versus LVM or Ceph. So what we've done is it's basically just a translation layer between the UI inputs, just mapping it to what the underlying Puppet inputs are. The process of adding an option would be you add it to the Puppet classes first, and then we evaluate what that option is. Is it something that could be defaulted? If it's not something that we can default or that we can generate from the other information that we already have, then we'll add a UI option for it. And once we determine that we need a UI option, then it becomes a matter of, is it something that the average user is going to need to configure or not? And that will determine whether it ends up in this wizard or in the advanced configuration.
And do you see a way where this data could be provided by the person who's writing the Puppet module? So that somehow it finds its way and expose, rather than having to hard code that in the plugin.
Yeah. So that was actually one of our bigger stumbling blocks. What we were trying to do was we were trying to make Staypuft very OpenStack release independent, which meant OpenStack would provide these Puppet classes, and we would configure them, or we would just consume them, and the UI would be dynamically generated. It's something that we would love to get to. It's something that we think is absolutely possible through enhancements to the Puppet classes. So just metadata, different metadata options on the various Puppet classes to give us additional help information. Some of the mapping stuff could probably be done there. It's a matter of, is it more important to do that, or is it more important to add features like the new networking configuration? So it's kind of been a balancing act, and right now it's simpler for us to just maintain the mapping layer ourselves, the hard-coding mapping layer. But we do definitely want to get to that automatic deployment where you can just consume the Puppet classes and the UI gets built from that.
Greg has asked if you can talk more about how you're using and extending Foreman Discovery.
Okay, so Foreman Discovery. And I can talk in detail about Foreman Discovery probably all day long because I used to own the Overt Node project upstream, which is what it's based on. But in just this, oh, I don't have it discovered anymore. 1 second. Let's see. Let's start this one. Okay, so once it comes up, I'll show you kind of the things that we've seen. A lot of the things that we've changed there have already made it upstream. Lukash, I know, has done a lot of the work for us. Some of the things are, for example, the discovery image at one point did not have the concept of this was the interface that was booting. So it would just report back the first IP address, which wouldn't necessarily be the IP address that we needed. So we made some fixes around that. We're adding an enhancement, I'm not sure if it's in yet or not, that will detect and report back the bare metal controller or the management controller. So for like IPMI control. So that information, so it can get back into Foreman so that we can consume it and configure the host correctly for our uses, which is especially important for HA. What else have we done?
We also added some patch to the facts, so we upload more facts. We can detect which network interface is active, which has the link, and also we upload all IP addresses and all information about all network interface controllers. So that's one thing.
Yeah. Okay, so this should be up now. So some of the things that I know we added, so we made sure that this IP address here, it's not as exciting on this VM because it only has one NIC on it, but we make sure that first the discovery boot IF gets reported correctly, that's the NIC that's on the provisioning network, and then we make sure that this IP address that gets reported, not just IP address ETH0, but the IP address itself, that matches with this NIC so that we can work just on the provisioning network initially. I know that work is being, all right, I'm pretty sure that the work is being done to report back disk information in addition to networking and CPU information. I know that there's other work too. I know that there's work being done to port the discovery image to run on RHEL 7. I know that that's just in flight at the moment. So those are some examples. I can't think of others off the top of my head, but I know that those are some pretty good examples of what we're doing.
Thanks very much. We've got a question from Lukash on Dynflow. He asks if you can show how it works and go into some of the orchestration code itself to see what it looks like.
Okay, not an area that I know very well, but let me see. So test was one I was deploying before. Show more details. So it's not, I'm not sure that this is going to show us very much because it's only one node that we're doing. But basically at this point, it's running this particular action. I can't talk too much to the orchestration code. It's just not stuff that I've worked on. But from a high level, what it's going to do is it's going to say, okay, here are all of my controller nodes, and provision these first, so install the operating system. Then after that's done, it's going to run Puppet on them, and it's going to wait for Puppet to complete. Once Puppet is complete on those hosts, then it's going to go back and it's going to run the same thing on the Neutron networker host. And then it's going to do the same thing, so it's going to run the same provision, and then it's going to run the same, or the appropriate Puppet classes for that particular host. And then once that's done, it's going to go back and it's going to do the same thing for all of the compute hosts. We do have plans to kind of streamline it a little bit. We're working on integrating Puppet SSH, which will give us a finer grained control, the ability to basically provision all of them at the same time and then say, okay, once they're all provisioned on the controller, run these Puppet classes. And then once those are done, then we can run the Puppet classes on compute or the network node. So that's kind of the high level of what we're doing. I don't know if I can go into more detail. I haven't ever actually looked at the code. But that's kind of what we're doing and where we're planning to go with it in the relatively near future.
Okay, thanks. We seem to be out of questions, unless Ohad has...
Yeah, I have another one. Out of your experience, is there anything that we could improve in Foreman that was difficult or non-trivial or something that you thought Foreman should handle and didn't? Or any tips for us to provide a better framework for you?
So we've been, or at least I've been fairly active with a couple of different issues that we've run into. Mostly it's been around like DHCP and DNS, so like the proxy-oriented stuff. I know I worked a lot with Greg on the DHCP proxy stuff, getting that to work right. We had a lot of issues with rediscovering hosts. So if we got into a deployment and we needed to basically scrap it all and start from scratch, or we just wanted to run a slightly different test, we would actually have to basically shut everything down, stop DHCP, wipe everything, go back. I think most of those things are fixed at the moment. And I know Marek is Foreman upstream as well, and he's been working with us on this. So I know all the networking stuff is going in. I guess the answer is more, you guys have been very responsive so far to our issues, which has been terrific. So I'm sure we're going to hit more things, and so keep being responsive would probably be the only thing I can say.
If I can add something, I think that the biggest issue was with the, let's say, orchestration of the Foreman proxy in general, especially DNS and DHCP conflicts and things around that. If something gets wrong, there's no way how to get back. So we should improve that. This was the biggest issue, I think.
Can you elaborate on that? I mean, we do have orchestration for those kind of things and conflict management. Is that?
Yeah. So what happened to us very often was that when we created a managed host from the discovery, it tried to create DNS and DHCP record, and sometimes when something fails, for example, there was some conflicting record, it failed in the middle, and there was no easy way how to get to the point before we tried to create a managed host. So we had to go to the DNS server and remove all records manually, clean all the cache and things like that. So I think it would be nice to have similar things like we have the Dynflow we currently use for orchestrating the Puppet runs. It would be nice to have similar thing for orchestration of Foreman proxy, so you could see what was created, which action you have to roll back and things like that.
Okay, I'm a bit surprised with what you're saying, because normally we do that and we roll back unless there's a code breakage, right? If sometimes that happens, of course. If during the plugin development you have some exception that breaks the orchestration code. It will be interesting to see the details to figure out what was wrong so we can improve. And I agree with you about that we could potentially leverage Foreman tasks. I think Foreman task was written also to answer this use case. So definitely we could try leveraging that and considering adding Foreman task as a default in a future Foreman version. The main issue I think at the moment is that it does not support Ruby 187, so we need to probably drop 187 support before we adopt it generally.
So just to elaborate a little bit more, so one of the things that we've seen a little bit more recently, so yes, as Marek said, we did have a lot of those troubles a couple of months ago, but I think we've worked through most of them for the standard use cases. One of the things we've noticed a little bit more recently that we're, I don't know if you'd say working around or just dealing with on the Staypuft side. So when a host gets removed, we haven't actually set up like all the different NICs on the host itself within Foreman. So it seems like the NICs are kind of flipping, or to what the host thinks its IP address is seems to flip from one NIC to another, not at random, but intermittently. So if we query it at one point, we might get one NIC, and if we query it at another point, we might get a different IP address reported as the host's real IP address. And what we've seen is sometimes that causes intermittent issues with removing the host either from DNS or DHCP, which means then you can't go and re-add the host again later. I haven't dug enough into it to see if that's exactly what's going on, or if it's something that we're doing versus something that Foreman is doing, but that's one thing that I know we've seen.
Right, this is a known issue where there's an option in the settings of Foreman which currently turn off by default, but there was a discussion whether to turn it on by default, whether to update, to ignore Puppet facts that are coming from the system and to update the existing host record in Foreman. So if you are in a multi-NIC environment and your IP address that factor reports is not the same one that Foreman initially had, we would if that setting is enabled, we'll update the IP address. And in cases where this happens, that's why we have this setting where users can simply disable that, and then MAC address and IP address will never be updated by fact, and then you won't have this problem. So all you have to go is to settings, provisioning, and then just disable that setting.
Okay, yeah, we'll look at that then, definitely.
And in such case, would other NICs would be updated, or it just ignores all new facts?
No. It's just the code that updates the MAC address and IP address. If factor simply returns a different IP, the trade-off here is between having an up-to-date system, with the relevant information, let's say if IP address changed for whatever reason, versus having what Foreman thinks is right and keeping it that way. So it's based on a user deployment and usage pattern, that setting. We can, obviously rediscuss whether that setting is right or wrong, and we can change that. But it's just the MAC address and the IP address as far as I remember. We have a similar challenges, by the way, with your operating system. If you ever do a YAM upgrade and change from RHEL 7 to 7.1 in the future, that will be updated on the host record itself as well from facts. So sometimes that's exactly what you want. Maybe in other times that's really not what you want. So it really depends how you're using it and so on.
Okay, I believe that we can improve the NICs updating, since when you have multiple NICs and you disable updating IP address and MAC address, you can still want to have updates of other NICs, and you can match using MAC address. So we should first look at whether there's any other interface with the same MAC address you had previously, and we can just update or improve the multi-NIC hosts, so we know when we should update it and when.
Okay, I'm interested to know if you guys if you have additional issues like that, you should tell us as quickly as possible so we can try and answer. I've seen this issue, on a pull request the other day, and that took probably a week for discussions until we got to the information that it's just a setting we can turn off. So hopefully in the future we can have a shorter round of discussion, maybe in the upstream channels or whatever not.
Yeah, I think in this case it was just something that we hadn't completely determined if it was something on our side or something on your side. So it was just we were still investigating it from our side and just hadn't pushed it upstream yet. But yeah, I know that we've had some other issues, and I'm sure Dominic can attest. I've moved a number of bugs out of our stuff into Foreman-related stuff over the past week or so. So I mean, we're still learning where the boundaries are between what exactly we're doing versus what's core Foreman.
Okay, and last question from my side. Are you planning a release of Staypuft upstream, so there's a version somewhere people can try, or alternatively, what would a user need to do if he wants to start using this to deploy OpenStack?
Yeah, so yes, we're planning a release. It's probably more in the Juno timeframe within the RDO community. I don't have specific dates. It's been enough of a challenge to get things working just within.
What would you recommend the user who's seeing this deep dive now and want to give it a try? Should be installing the nightlies, or is there a place to go for searching for documentation and help?
So I would probably say a pure upstream user, you can go with the nightlies. I can't guarantee they'll work, but if you go with the nightlies, you definitely want to use CentOS and not Fedora. I know for a fact that the Puppet classes aren't really tested or exercised on Fedora. So definitely, you want to deploy to CentOS. As for support, you can try the RDO channel on Freenode. To be honest, there's not going to be a whole lot of support out there in the next month or two. Everyone who's working on this has been very downstream product focused, unfortunately, very recently. But I'm on the upstream Foreman channels. I'm on the upstream RDO channel, so you can try to ping me. Time permitting, I can help.
Okay, and if you find a bug, you open it on the Foreman or tracker or on Bugzilla, or?
So we don't have Bugzilla components at the moment, so opening a Foreman issue against the Staypuft component, or whatever the terminology is, but a Foreman issue against Staypuft, and at the very least, someone will see it, and we can turn that into bugs as necessary, or we haven't really figured out the true upstream workflow yet, but a Foreman issue for now will work just fine. Okay, any more questions from IRC or the YouTube channel?
I don't think so. I think we're done. Thank you very much, both to Mike and to Marek. And the recording will go up on YouTube and onto our website. Thanks once again.
Thanks, everyone.
Thanks a lot.